Okay, Science 10s, and moving right along here, we're on question number 4. Homer has a mass of 85 kilograms. What is the force due to gravity on Homer? Well, force due to gravity is equivalent to the weight of the object. It's the product of m times g, where g is a constant value. Okay? So writing down my formula. Now this is a small little subscript g, and then this is g as your variable. So I'm going to put in 85 kilograms, multiply that by the 9.81. Okay? I get 833.85, which we'd round to 834 newtons. Okay? All right, work. Work is done when a force is applied to an object and that object moves in the same direction as the applied force. When work is done to an object, that object will experience a change in energy. So work is the product of force times distance. Symbolically, W equals F times D. Now the units of work are the joule, capital J, which is equivalent to an N times M, or a Newton meter. Energy. Whenever work is done on an object, there will be a change in energy. So work is a change in energy. Now this delta notation really means change in. Whenever I see a delta, that's what it means, right? So symbolically, W equals the change in energy. Units, of course, of work and energy are both capital J joules. All right, here's some examples. I have 2 of them to do. The force of 50 newtons is used to push a 20 kilogram car at a distance of 15 meters. How much work was done? Well, the formula, W equals F times D, and we have 50 newtons multiplied by 15 meters. We have 750 Newton meters, which we would term a joule. But we want to make sure we're paying attention to sig digs, and so we have 2 sig digs here, 2 sig digs here, and so my answer should be 7.5 times 10 to the second joules. And in part B, what is the acceleration of the box? Well, acceleration should be the ratio of force to mass. So 50 newtons divided by 20 kilograms is 2.5 meters per second squared. Okay? Now, question number 2. Homer does 300 joules of work to lift a box decimal 8 meters and put it on a table. Part A, how much force did Homer use? Well, if work is equal to F times D, then the force should be the ratio of work to distance. So 300 joules divided by 0.8 meters. Okay? 300 divided by decimal 8, I get 375, but there's 2 significant digits here and 3 here, so my answer should only have 2 significant digits. I'm going to write down 375 newtons, and then I'm going to round it to 3.8 times 10 to the second newtons. Okay? Part B, what's the mass of the box? When you lift something up, what you're really doing is you're using the force due to gravity. So using Fg is what that's about. And so the mass of the box is found by using this formula. Fg is equal to m times g. And so the mass should be, of course, the force due to gravity divided by the g value. And so this would be 375 newtons over 9.81 meters per second squared. 375 is in there, divided by 9.81, and I get 38 kilograms. All right, thank you very much for joining me on that.